know, it's interesting. I had a student from North Arvada the other day, and I looked at his Inspire CX, and it had all of the capabilities that mine had.
My math teacher told me that the one you have isn't allowed on the ACT or anything like that.
Okay. Okay, I believe that. Huh. I'll have to tell my other student that. I don't know how they're going to tell, because they look exactly the same. The only thing different is
I don't think they can.
It's going to be very difficult for them to check everybody's calculator to see which kind it is. You would think that CAS specifies the calculator, but it really doesn't. It's all about the version of the software.
Yeah.
Well, better this way, actually. I actually think it's better if you have to learn how to factor and complete the square and all of that. I don't think you want a machine doing all of that for you.
All right, I'm sending you problems now.
Okay. What kind of stuff are we working on today? What is it? I haven't got
like square roots and stuff like that.
Okay, radicals.
Yeah.
Whoops. Excuse me one moment. Got a buzzer going off here.
All right, you just sent.
You just sent it?
Yeah, I just finished sending.
Okay. There it is. Want to start at 1?
No, go to 16 through 25 is what we were working on.
Okay. 16 being this one. Y
Or
squared
15,
equals,
sorry. 15.
I can't quite see 15. 15 must be x squared equals 144?
Yeah, the numbers just got cut off.
That's all right. And it's not any big deal if you have to verbalize part of it. All right. So if x squared equals 144, what is x equal to?
12.
No.
Or
The reason I'm hesitating is because everybody misses this, and I can't quite figure out why. It's plus or minus 12.
oh.
You see why minus 12 is a solution?
Yeah, because if you square it, it comes out positive.
Exactly. But whenever you're taking the square root of both sides of an equation, do not forget that plus or minus. You will miss the problem. If it's a test of any kind, you will miss the problem if you forget that plus or minus. So just remember. And that is one of the hardest things for my students to remember for some reason. I'm not sure why. But All right, 16, y squared equals 0.
Wouldn't.
Take the square root of both sides.
So it's just y equals plus or plus or minus 0.
Exactly. Only that's the same as 0. Because plus 0 is the same as minus 0.
Mm-hmm.
Okay. And I can't see the last number on this 17.
X squared plus 9 equals 0.
Notice what we have here. We're taking a number that has to be positive. We're adding a positive number to it, and it's going to be 0. So this can't be a normal math problem. It's the next step in solving this.
Would you subtract 9 from both sides?
Then,
X equals would it be -3?
don't forget the start. Remember that whenever
Is
you
it plus
take
or
the
minus?
whenever you take the square root of both sides, always know that your answer begins plus or minus
Every time?
every time.
Okay.
Now let's simplify that. What is the square root of minus 9 equal to? Factor it. By factoring it, I mean it's the square root of minus 1 times the square root of 9. You see that?
Yeah.
Okay, now what's the square root of 9?
3.
And what is
Plus
the
or
square
minus
root
3.
of, and what's the square root of -1?
Negative plus or minus -1.
No, that's I. That's what I is.
Oh yeah, that's right. This is all coming back to me from this week.
Okay, so this answer is plus or minus 3I. You need both the plus or minus, and you need to take the minus 9 and separate it into that.
Okay.
Read 18 to me.
Y squared minus 7 equals 0.
Okay, what's the next line?
It'd be y squared equals 7.
And the next line.
Y equals plus or minus square root of 1 and square root of 7.
Just square root of 7. In other words, there's no negative numbers here, so we don't need to factor it. You obviously could factor it to square root of 1 times square root of 7, but square root of 1 is 1, so it doesn't change anything. So
Yeah.
this really is our final answer here, right here.
Okay.
And let's see, 19, we have 9x squared equal 4. Next line.
Could you divide by 9 on both sides?
Yes. In other words, your immediate task is to get x isolated. The first thing to do is to get rid of the coefficient of 9. What's the next step?
X equals plus or minus square root of 4 ninths.
Okay. What is the square root of 4 ninths?
Would it be 2/3?
Yes. There's your answer. What does this say? 25y squared equals what?
-16.
First step?
Isolate y, so divide by 25 on both sides.
Next step?
Did you forget a negative sign on 16?
Ah, I did. Thank you.
Y equals, hold on, actually you could simplify that fraction.
You can, but it might not be something you want to simplify. Why is that? Because our next step has to take the square root of both of these numbers.
Okay. So y equals plus or minus square root of -4/5.
Well, if we take the square root of 16, we get 4. If we take the square root of 25, we get 5. So that's our answer except for the negative sign, and that's I. So it's plus or minus 4/5 I. In other words, I left out a step here. Let's go back because this isn't always obvious. So y equals the square root plus or minus the square root of -1 times the square root of 16 over the square root of 25. You see how I get from this step to that?
Yeah.
Okay, and that's an important step because it always clarifies the issue for you. Because you know what square root of -1 is, that's I. And square root of 16 is 4, square root of 25 is 5. So it comes out plus or minus I times 4/5, which is the same as 4/5 I. But this step where you take out the -1, I find to be helpful myself. I mean, after you're doing it for a while, you don't need to do that. You just need to change that to a positive and remove an I. But when you're first doing them, it actually is quite helpful to factor that into -1 times the other number. And what does 21 say?
21.
Yeah, I can't quite read
16y
it.
equals 25.
16y or y squared?
Oh yeah, y squared.
Okay.
(25/16). Y equals square root of 5 over the square root of 4.
You forgot something.
Plus or minus.
I don't know why that is so hard to remember. It's hard for me to remember. If I haven't done this for a while, I'm liable to make that same exact mistake when I first do it.
Yeah.
But I guarantee you it will cost you points on a test.
Oh no, she said it would.
Oh yeah, for sure. What's next, 22?
Yeah.
First and second step.
First step would be to isolate x or get the 81 to the other side.
Get the 81 to the other side.
Okay, so 9x squared equals 81.
Okay.
And then you have to divide both sides by 9, so x squared equals 9. X equals plus or minus 3.
Yeah, now let's just look at that from a slightly different perspective. Notice that this is the difference of perfect squares. How does that factor?
That'd be 3x plus 9 and 3x minus 9.
now when we solve each of those, we get x equals minus 3 and x equals plus 3. Same answer. Okay. 23, we got 4 minus 16 something.
16x squared equals 0.
Okay. Next line.
Negative 16x squared equals negative 4.
You know, I'm going to suggest a different next line. It's not a big difference. It's just very subtle. Whenever I have a chance, I like to keep all of my numbers positive rather than negative. If I have a chance to create an equation that's got negatives on both sides, I'm going to do it so that it's got positives on both sides. So instead of subtracting 4 here, I'm going to add 16x squared.
Okay.
Notice no negative numbers now. Doesn't matter whether your x is on the left or the right. I personally believe that it's more helpful to make the coefficient of x be positive if you can.
Okay.
So now I have x squared equals 1/4. What is x equal to?
X is equal to plus or minus the square root of 1/4.
Which is?
1/8.
Square root of 1 over square root of 4. What's that number?
1/2.
Okay. What's 1/2 times 1/2?
1/4.
Okay. Let's talk about that principle for a moment. When you square numbers that are greater than 1, you get numbers that are bigger. When you square numbers that are less than 1, you get numbers that are smaller. Very, very important concept in math. So if you square 1/2, you expect to get a number that's smaller than 1/2, and indeed you do. And when you work that principle backwards, it's very difficult for a lot of people to see this, but when you take the square root of 1/4, that has to be bigger. In other words, if when we square 1/2, we get smaller, if we take the square root of numbers between 0 and 1, they have to get bigger.
Okay.
A difficult concept to a lot of people to accept is that when you take the square root of a fraction, you're going to get a bigger fraction. If I take the square root of 1/9, that's equal to 1/3, which is bigger than 1/9. Notice something else here. When I say the square root of 1/4 and I write it like that, that implies the positive square root. Notice that I did not write a plus or minus in front of my half. Same thing with the 1/9.
Okay.
And the reason that is because math has to have the ability to distinguish between this and this. So this would be minus 1/3. This would be plus 1/3. It's not plus or minus just because we take the square root of it. The moment you write the radical sign, you're saying you're assuming there's a plus sign in front of that. Just like whenever you write any number, you assume that there's a plus sign in front of it unless you put a minus sign in front of it. Okay? So solving the square root of 1/4 is much different than saying x squared equals 1/4 and solving that. This answer is definitely 1/2. This answer is plus or minus 1/2. See the difference?
Yeah.
All right. Where do we leave off?
23.
24. What is
Oh,
24?
no, we already did 23. 24.
What does 24 say? I can't quite read it.
0 equals 4 plus 16x.
Squared. Okay. Next line.
Negative 4 equals 16x squared.
Next line.
It would be
And simplify.
negative 1/4 equals x squared.
And next line.
Plus or minus 1/2.
I. Don't
Yeah.
forget the I. In other words, if it was x squared equals 1/4, then x would be equal to plus or minus 1/2. But when it's x squared equals negative 1/4, know that we have to be talking imaginary numbers because you can't square something and get a negative sign.
Okay.
So the moment you're taking the square root of a negative number, know that your answer has to have I in it.
Okay.
And just the I represents the negative sign. Everything else represents the 1/4.
Okay.
Equals 9, whoops, 81 minus 9x squared equals 0. Next line.
81 equals 9x squared.
Good.
9 equals x squared. X equals plus or minus 3.
26. What does 26 say?
25y squared plus 16 equals 17.
That was 25y squared?
Yeah.
Like that? Okay. Next line.
25y squared equals 1.
And next line.
Y squared equals 1/25.
And next line.
Y equals plus or minus. Would it be the square root of 1/25 or just 1/25?
Well, it's the square root of 1/25, but that can be simplified. In other words, at this point right here, you have to take the square root of both sides.
Okay.
So I definitely have to take the square root of 1/25. What is that? Remember, when you take the square root of fractions, they get bigger.
1/5.
There you go. All right. What do we got next?
I got some problems.
Okay. You can read them. If they're like this, they're very easy to verbalize. You don't really need to send them to me. You know, if they're graphical in nature, a different story, but
Yeah, these ones are a bit more challenging.
okay. You can send them to me or verbalize them, whatever you like. Is this stuff we're covering the stuff you've covered in the last 3 or 4 days, or is it stuff you're going to cover next week?
No, it's stuff we've done in the past couple of days, and we're going to continue to do this week.
Okay, I was going to say, you seem to know this stuff pretty good. It might be worth getting a head start on next week's material, but if it's the same stuff, let's just go ahead and do some higher degree of difficulty problems.
Yeah. All right, it's sending.
Okay. I leave my email closed when we're in session because, boy, no matter what I have open, it takes away from my resources. And sometimes it messes up my sound.
What kind of computer do you have?
I use Windows 8. No, Windows 7, I think. What about you? You have an Apple?
No. I have a Windows XP.
Okay.
Just straight standard Windows 7.
It's a laptop?
Yeah.
Do you know what kind of processor? Do you have a dual processor or a quad processor in there?
I think I have a quad-core Intel i5.
Okay. What kind of internet do you guys have?
I don't know the specifics. I just know that it's 50 megabytes a second, and it's on Comcast.
Comcast, okay. Because you and I never have audio problems. And yet some of my students I have audio problems with, and I gotta believe it's because of their internet connection, not mine. So you got the latest and greatest from Comcast.
Yeah.
I actually am on a Delphi, which is the other one.
If we ever have any problems, it's probably because of mine, because I am about the farthest away from my router that I can get in my house. So.
Okay. So you're on a wireless connection to an internal router, okay. But you and I don't ever have any problems, do we? Have you ever remembered us having any audio difficulty? And that's usually where it shows up, the first place, is the audio.
Nope, I haven't had any problems.
No, I don't remember any either, but I have a couple of students living in the same area that you live in that every time we have a session, the audio is shaky, breaks up, to the point where I actually call them on the telephone and conduct the session with the audio being over the telephone instead of the internet. It's the only way around the problem. But I don't know whether they have Comcast or the other. Okay, your email came through.
That writing in the book's not mine.
What kind of phone are you using to take these pictures?
Samsung Galaxy S2 Skyrocket.
You know what megapixels your camera has?
I believe it is 8. Yeah, it's 8.
8? Yeah, these are pretty good pictures.
Yeah.
I was going to say these are I only have a 5 megapixel, and I don't get quite this clarity, but the clarity also depends on how still you keep the camera when you take the picture.
Yeah.
I've noticed.
What kind of phone are you using?
I have a Droid. It's a Motorola Triumph.
Okay.
It's the Android operating system, but the camera is only 5 megapixels. But actually, that works okay for scanning, math stuff into my computer, as long as I hold it steady. If I shake it all, it's too blurry to read. But,
yeah.
Love to get these new Google glasses that are coming out. But they're only 5 megapixels on their camera. which is a little shocking.
They might not have room for much else.
Well, that's so tiny what they have. Have you seen a picture of the Google glasses?
Yeah, I've seen a couple like review videos about them and stuff.
Yeah, they seem cool. I mean, I got to think that's the next big thing. But that 5 megapixels is going to need improving because every other camera out there is better than that now.
Yeah.
All right, what's the first step here?
Subtract 8 from both sides.
No, notice that this is a quadratic. How do we solve quadratics? We get everything on one side and 0 on the other.
Yeah. So 5r squared plus 12r plus 8 equals 0.
Now, why not, as a test, put this into your calculator, get the zeros, and then figure out what the factors are?
Why not do that?
Let's do it. Surely you're going to want to do that on a test if you don't know how to factor.
Oh yeah, I did it on the last one.
Yeah, so let's try it. I want to make sure you get the fractional point part right.
It just gave me a blank answer for some reason. I don't know why.
Well, maybe this doesn't factor. Maybe this has imaginary factors. No, it wouldn't have imaginary factor. Well, it might. Let's see. 12 squared minus 4ac, 4 times 40 would be 160. It does give you imaginary factors. In other words, what I just did in my head was calculate what the discriminant was. The discriminant being b squared minus 4ac, which is 144 minus 4 times 5 times 8, which is 160. That is a negative number, which means the factors are both going to be imaginary.
Okay.
And your calculator, the way you did that, you probably specified real. Go back and try it again and specify imaginary in that second position.
I have the options of real or complex.
Complex.
Okay.
What'd you get?
I got negative 6 over 5 minus 2 over 5i, and then negative 6 over 5 plus 2 over 5i.
Those are your two solutions. Now, the factors are x minus these numbers. Just like every time you get a solution of x equal 3, the factor is x minus 3. Or x equal 5, the factor is x minus 5. So if I'm going to put factors up here, and I don't know what this says to do, solve each equation after rewriting it in the form ax squared, give answers involving radicals in simplest radical form. So it really doesn't want factors, it wants answers. And you've got those. These two that you gave me are the zeros.
Okay.
Okay? However, if the question said factors, notice that if I subtract this quantity, minus 6/5 minus 2/5 I, and I subtract this quantity, minus 6/5 plus 2/5 I, the answers end up being very familiar to what you would expect to get. Those are my two factors. Notice that they're pretty much the same answer as we had, except there's a positive sign in front of the 6/5. So it's not really it's not really the same. You really do have to subtract these from x in order to get your factors. Now, if you were to put these two linear factors into your calculator and say multiply, you will get this.
Okay.
So I'm just, make sure you understand the difference between the answers and the factors.
Okay.
Okay?
Get 3 to the other side, so 2w squared plus 4w plus 3 equals 0.
And this time let's do this without your calculator.
Okay.
Pretty sure it's not going to factor, right? Just because the section we're in has to do with complex numbers and quadratic formulas. So I would be very surprised if this factored.
Okay.
No, it does not. So let's solve it using the other method other than your calculator. Don't use your calculator on this. What's the quadratic formula?
Negative b plus or minus the square root of, is it b squared?
Remember that, because remember that's called the discriminant. And it's very useful to test that to see whether or not it will factor or not. Notice that b squared here is going to be 16 minus 4 times 2 times 3. That's a negative number. That means we're going to have complex solutions. We're not going to have real solutions, which means for sure that it doesn't factor. In other words, by doing a quick check on the discriminant, we can tell whether we should spend any time at all trying to factor this the normal way. The moment we realize that the discriminant is negative, we know we have to use the quadratic formula. So let's proceed. So fill in.
Negative 4. Negative 4 plus or minus square root of 16 minus would it be 24?
Yeah, well, just put a 2 in there. Let's not do it in multiple steps. Let's do it in single steps. Okay. Now let's simplify.
Square root of 16 minus
16 minus 24 is minus 8.
Okay, yeah.
Okay, so we have the square root of minus 8 over 4. Simplify again. So square root of minus 8, that can be simplified.
Square root of negative 1, square root of 8.
Which can be simplified further. Square root of 8. What are factors of 8 where one of the factors is a perfect square?
4.
Okay? So what is the square root? So what is the square root of minus 8 equal to?
Square root of 4 and square root of 2.
So it's the square root of 4 times the square root of 2 times the square root of minus 1, correct?
Yeah.
Now simplify that. It's the square root of 4?
2.
Now one last simplification. to get it into A plus BI format. Split it into two fractions. That one's the first one.
Negative 4 over 4.
Which is?
Negative 1. And then 2 square root of 2I over 4.
What are you going to do with this 2 here and this 4 here?
Are you just going to make that into a fraction?
Of 1/2. In other words, you left out the 2 on the denominator when you gave it to me the first time.
Oh.
Okay? In other words, the 2/4 becomes 1/2. And this is in A plus BI format. A is this, B is that. Well,
Okay.
actually, excuse me. B is this. Square root of 2 over 2.
Okay.
Okay. 9. What does 9 say?
9 is 3y squared equals 1 minus y.
Okay. Next line.
Negative 3y squared minus y plus 1 equals 0.
Try to keep everything positive numbers. How are we going to do that?
Move the y over.
Move the 1 and the y over.
Yeah.
Remember, it's a quadratic.
Yeah.
When you're solving a quadratic, you usually want to put it in standard format, which is ax squared plus bx plus c. So what's my next line?
3y squared plus y minus 1.
Equals 0. Okay. This is not going to factor either.
Yeah.
Can you tell that instantly when you look at it?
Some of them, yes.
Well, notice that this can only factor into 3y times y. This can only factor into 1 times minus 1. So one of those 1's has to multiply a 3. The other one has to multiply a 1. There's no way to get a coefficient of 1 in the middle term.
Yeah.
So I know as soon as I check that I need the quadratic formula here.
Okay.
Help me?
Y equals
It's minus b.
negative y. Would it be negative y or just negative 1?
Negative 1. Remember, b is merely the coefficient of the y term. Doesn't include the y.
Okay, and plus or minus the square root of just 1 squared minus 4, 3, and negative 1. 2 and then in parentheses 3, so 6.
Simplify.
Negative 1 plus or minus that would actually be 1 plus 12, wouldn't it?
Yep. And simplify one final time because it's not yet in A plus BI format.
Y equals negative 1/6. And then y, or not y, yeah. would just be square root of 13 over 6.
Yep. Okay. What's that, 9?
3y squared minus, or
No,
3y squared.
I think that's the one we just did was 9. That's what I said. What was
8x.
that? Yeah. So 10 is 8x equals 1 minus x squared.
X squared plus 8x minus 1 equals 0.
Again, we can see that there's no amount of factoring. 1 times x and 1 times x is never going to get you up to 8x. So, quadratic. Is there any way for you to put the quadratic formula on your calculator so that you don't have to memorize it?
I don't know. I'm not sure.
You have notes. You have the ability to open a document and type in stuff. So I would think that between your keyboard and your documents, you'd be able to put it on there. If you have trouble memorizing it. If you don't have any trouble memorizing it, then it's not worth the effort. But if you ever find yourself not being able to recall it instantly, you need it on there.
How would you write plus or minus on there?
Probably plus slash minus like this.
Okay.
Using the keyboard.
Yeah.
So what is x equal to here?
-8 plus or minus the square root of 64 minus 4, 1, -1 over 2.
So I think at this point you've probably memorized it and you don't really need it on your calculator anymore. In other words, after you do a number of these, you end up memorizing it whether you want to or not. Okay, let's simplify. And when I say simplify, I always simplify in multiple steps. I don't try to bring this down to a plus bi format in one step. Too much chance of making a mistake. So let's simplify it. Let's simplify the radical first.
The radical would be negative, I don't know, it'd be just 60.
Is it 64 minus 4 or is it 64 plus 4?
Yeah, plus 4 is 68.
Now let's figure out what root 68 is.
Could you?
Is there a perfect square number that divides into 68 perfectly?
Yeah, 4.
Okay. So square root of 4, and what's remaining? Square root of 17. Okay, that looks like a prime number. Once you see a prime number, you know you can't reduce that any further.
Yeah.
So that's 2 root 17 is what root 68 is.
Okay.
So let's go back up and put 2 root 17 in there. And final answer?
-8 over 2.
-4.
Yeah. And then 2 root 17 over 2.
Plus or minus, the 2's cancel, and I just have root 17.
Okay.
In other words, make sure when you split this into two fractions that you simplify it at the same time. The
Would it be marked off?
I'm
if
sorry?
I'd forgot to cross out the 2's?
I bet you would. Yes.
Okay.
In other words, part of what you're doing is always simplifying. You would never give an answer of 9/3. You would give an answer of 3. If you gave an answer of 9/3, I bet you would mark off.
Okay.
Maybe not as much, maybe not the full value, but pretty sure she would mark off something. Are we on 11 now? Yeah, I don't remember 11.
Yeah.
This is good because this is what I would call drilling. In other words, we're taking one principle and one principle only, and we're doing multiple problems with it. And I like that because you're going to be expert at this type problem before we're done, as opposed to doing one quadratic and then going to cubics or quartics or some other type problem. You see what I'm saying?
Yeah.
Okay, so what's this?
2x squared plus 2x and then minus 7.
And
X.
now the question, Jackson, kind of becomes, do I spend time trying to factor this? Well, every other problem we've had in this section does not factor.
Yeah.
So if you're taking a test on this section, I go straight to the quadratic. I don't even try to factor it because I'm pretty sure it doesn't factor. And the worst case scenario is that even if you go to the quadratic, it'll give you the correct answers. In other words, if it did indeed factor, quadratic will still give you the proper answers. You'll never go wrong by using the quadratic. It just may not be the easiest way to do it.
Okay.
But given the section we're in, I would immediately go to the quadratic and wouldn't bother with trying to factor it.
Okay.
Minus b?
Negative 2 plus or minus the square root of 4 minus 4, 2, and then negative 7 over 4.
Simplify the radical part.
I think that's negative 52.
Plus 4, right?
Oh, I keep...
No, you're right. Let's see, it's 4 times 7 is 28, times 2 is 56, plus 4. So it's 4 plus 56.
Yeah.
And root 60 becomes what?
You could do 4, square root of 4, and then square root of 20. Or no, oh yeah, 15, sorry.
Now notice root 15 becomes root 5 times root 3, but that is not helpful, so we leave it as root 15. I don't want to turn this into 2 radicals, ever. I want to turn it into a radical and a whole number if I can, but I can't do that with root 15. I can only turn it into 2 radicals, root 5 times root 3, so I leave it as root 15. So I place that as 2 root 15. And now what's the final answer? In A plus BI format.
Yeah, it's for x equals negative 1/2. And then 2 root 15 over 4.
Plus
Yeah. And then, would you simplify that 2 and 4?
Yes, always.
Okay, so 1 root 15 over, yeah.
Just think of it as a coefficient. In other words, don't think of it as 2 root 15 over 4. Think of it as 2/4 times root 15.
Okay.
And then 2/4 obviously becomes 1/2. All right, let's see. What was that, 11? Yeah. What does 12 say?
12 is 5 equals 4r, and then in parentheses, 2r plus 3.
Okay. Next line.
8r squared plus 12r minus 5 equals 0.
And r equals...
Negative 12 plus or minus square root of 144 minus 4, 8, negative 5, all over 16.
Yeah, what's the radical? Always
160.
notice that when you have two minus signs, that means we're going to be adding this number to this number.
Mm-hmm.
So it'll be a whole number. I mean a positive number, rather.
So that's 144 plus 160, which is 304.
Okay. Now, root 304. Is that divisible by 4? You know how to tell?
Yes.
To tell whether a number is divisible by 4, look at its last 2 digits. That's all you need to look at. In other words, this number is divisible by 4 because 8 is divisible by 4.
So if it has an 04 and 08 at the end of it, it's always divisible by 4?
Or a 12, or a 16, or any, if the last 2 digits are divisible by 4, because notice the 300 is always divisible by 4.
Yeah.
100 is divisible by 4. 200 is divisible by 4. So the only thing that needs to be divisible by 4 is what's left over after the 300, and so the last 2 digits.
Okay.
So let's see. This is root 4 times what?
Root 76.
Hold it. You're right. 4 goes into 37 times with 24.
Yeah, that's 76.
76. Okay. Now, is 76 divisible by 4?
No. Wait.
No, you're right.
Yes.
It is not. Oh, yes. Yes, it is, actually.
Yeah, it is.
Okay, so let's do it again. In other words, this is kind of a good illustration of where we don't have to figure out the maximum perfect square in there. In other words, this number was actually divisible by 16. We just didn't see it. But it's okay. We'll still get to it because square root of 76 is square root of 4 times square root of 19.
Okay.
Now, the square root of 4 and square root of 4 come out as a 4. So there's our simplification. We know that's simplified because 19 is prime. So 4 root 19 is what we want to put up here. And simplify this.
X equals negative 3/4, or R, sorry, yeah. And then, so 1/4 root 19.
Yeah, good. I like that thinking better rather than root 19 over 4. All right. Well, it sure looks to me like you understand how to do these.
Good, because I sure didn't a couple days ago.
Well, good. Good. That's usually on... This is really the way math should be learned, is you should take a principle and spend a given amount of time practicing it, drilling it, you know, doing 20 problems that are all the same principle. I guarantee you, you'll remember this for 5 years, at least. How to solve quadratics using the quadratic formula.
Okay.
All right?
All right.
Jackson, I will talk to you. When is our next session scheduled?
I believe it is Tuesday, but I also want to see if we can get one in on Wednesday. I still have to talk to my mom about it because I have a quiz either Thursday or Friday. What is what my teacher told us?
Okay, let me bring up my week here. Let's see, next week. I can certainly give you a half hour on Wednesday. Let's see, we have a half hour on Tuesday scheduled from 7:30 to 8. And,
Oh yeah, by the way, football is over now, so I'm free like most of the afternoon and evening.
okay, well, here's my schedule for next week. You pick an opening, whatever you like.
Okay.
You want Wednesday from 3 to 3:30, you could have it, or from 2:30 to 3, or whatever. In other words, my Wednesday is fairly full. I do have an 8:30 to 9 available.
If I were to choose one, I'd probably do the. Is that a 5:30 to 6?
Yes. You want 5:30 to 6 or 5:30 to 6:30?
Yeah, let's schedule that, and then I'll text you if anything changes.
Half hour or an hour?
Half hour.
Okay. Oops, hold on. You got it. I will talk to you Tuesday night at 7:30.
Okay.
All right? Okay, Jackson.
All right.
Bye-bye.
All right. Bye. Thank you.